So section 6.2 is taking a curve and rotating it around an axis and then finding the volume of it. So we're going to take this one first. So this is the curve y equals rad x, and it's rotated around the x-axis. And the crosshair, when you cut into the shape, you get discs. So the area of these discs is a equals pi r squared. So you take that, so the r is f of x, so that's rad x, so r squared is just x. So our area is pi x, so the volume is pi x dx. So we plug that in for the volume, so the integral of 0 to 1 of pi x dx is, so you take the antiderivative and you get pi x squared over 2 from 0 to 1, and that just ends up being pi over 2. Then we're going to do this one. So this is two different functions that are rotating around the x-axis in order to make a three-dimensional shape. So the equation for this is the volume of the outside minus the volume of the inside. So v of t equals pi, the integral of 0 to 1, so this is 0 to 1, and then the outside equation is rad x, so rad x squared dx minus pi of the integral of 0 to 1 of x squared squared, so that's this one, dx. So we have volume equals pi of the integral of 0 to 1 x minus x to the fourth dx equals pi of x times the quantity x squared over 2 minus x to the fifth over 5 from 0 to 1, and we simplify this and plug everything in. We get pi 3 over 10.